So good morning, everybody. During this session, I'm looking forward to sharing our experiences with the sorts of things you can do with vector graphics that are contained inside of PDF documents. Before I get started, I just want to pick up on a couple of themes that I've sort of picked up on over the last couple days. First was David Blattner, who talked about kerning and nuance. Being in the business of graphics, we care a lot about how things look, and our customers tend to care about that too. They put a lot of work into developing their PDF, and they want it to look exactly the same when it's going into another format or displaying on another system. And you become, once you start noticing good design, you become more sensitive to it. Dove talked about the mindless mantra of where PDF goes to die. And while I agree wholeheartedly with his approach of attaching data to PDF files, sometimes that just simply isn't possible. Sometimes it's interesting to pull meaningful information out of PDF. It's not always scraping, which sounds kind of negative. Sometimes it's targeted extraction with a purpose. And sometimes we don't need the data, we just need a visual, and that's what we're trying to mine from a PDF. So a lot of the discussions here have been about getting organizations to adopt more of the PDFA standard, but we also have to respect the number of PDFs that exist today. It's an overwhelming number. As Kenny Swope said, part of the digital transformation is looking at that content that we already have and trying to leverage more information from it. And that's basically what a lot of my presentation is going to be about. Okay, my name is Jean Haney. I'm the co-founder and CEO of Visual Integrity. Jan Homan is my partner, and he and I started the company together in 1993. It was the same year that Adobe first released Acrobat and PDF. Up until that point, we had already built up a good deal of experience in developing vector drawing applications, as well as converting vector graphics into PostScript, converting the vector graphics from PostScript and EPS files into vector formats like WMF, SVG, CGM, and MIF for TechPub systems. Back in those days, a lot of content was being created in engineering companies on Sun and other workstations, and they mostly output PostScript, but the TechPubs people needed to use EPS or MIF or another format in their technical manuals. So that's sort of where we got our start. And between the two of us, we have, and I really hate to admit to this, almost 70 years of experience in these vector graphics technologies, products, customers, and workflows. So I know that you're a technically astute audience, so I'm not going to spend a lot of time talking about the difference between raster and vector graphics, but I am going to set the stage for anybody who may not be in this world. So then we're going to talk a little bit about how end users can use PDF today, the graphics in PDF, how integrators are using them to automate workflow solutions, and for developers to look at how they can access and work with vector PDF information in their applications at both the file and the object level. Okay, so first, vector versus raster. The first thing we ask ourselves is, what is visual information? And visual information is all of the things you see in this chart. Let me just find my place here. You've all heard the adage that a picture is worth 1,000 words. And when we think of pictures, we probably think of both photos and line art. The average user might never stop to consider that these are, by nature, very different types of graphics. Photos are made up of pixels, while illustrations are made up of objects derived from data. Pixels are just dots on a screen or page, devoid of any information about what they collectively represent. On the other hand, illustrations are rendered from data. Every line, character, object, group, and layer contains rich amounts of information that could be extracted to further understand or drive your business. A little bit about, this is sort of in line with what Kenny Swope was saying in his presentation this morning, about how you can have a huge locker of information, of PDFs in your business, but the digital transformation is sort of trying to figure out how to mine those documents from even more information when you can see them digitally versus just on paper. So this slide summarizes many of the types of visual information which contain data. These are vector graphics, and that's what we're going to focus on today. So scanned documents are raster documents. They're raster PDFs. Even though they look like drawings, act like drawings, and say drawing in neon on them, they're still bitmapped images. They're like photocopies or photographs. They're a snap from a moment in time, and there's no intelligence in them at all. You can't leverage what is lost. So there's not much we can do with scanned files. Computer-generated documents are primarily vector PDF files. But remember, garbage in, garbage out. When a lot of people create PDFs, they don't give so much attention to the graphics. Even if it was computer-generated and was a vector, they might take a screen snap of it, or they might just, or a lot of the conversion engines out there will just convert all of the graphics to bitmaps. And that information is lost. So what we're advocating for is to try and keep as much of the vector in your file as possible. Why do I say primarily? Because in a PDF file, the fonts, the graphs and charts, the callouts, the block quotes, the logos, drawings, schematics, tables, that's all vector information, and there's intelligence in there. The raster information would be the photographs, the screen snaps, the original art that might be in there. So basically, the way to look at it is that rasters come from paint programs and scanners, while vectors come from any kind of illustration package, technical drawing package, and original line art. Okay, so maximize your vector content. This image right here is basically just showing the difference between a bitmap and a vector, and I'm sure that you're all familiar with that. The great thing about vector graphics are that they're clear and crisp no matter how large or small they are, and this is a really important thing for responsive design on the web, for display on all different size devices. Vectors are device independent, resolution independent, simple to edit, searchable, actionable, intelligent, and precise. Okay, so what I'm going to do now is switch gears a little bit and talk about actual examples so that you can see the way people right now are looking to use the graphics in their PDF documents. And these are all examples of real customers or real products that exist today that people are using to do this. We'll start with PowerPoint. And this is an example where so what we started with was the World Wildlife Fund's 2017 annual report downloaded from the web. And let's imagine that we're a local organizing group and we want to try and get contributions for the WWF. So what happens is we go to the document and we go to the first page, we open it up in PowerPoint, we grab the logo, and then we're going to grab a graphic which talks about how important individual contributions are to their program. And when we go through that, you see that you can, it's up here on the left, I knew it was going to be pretty hard to see. You see the original, this is the page 30 of the annual report, that's the number 2 slide, and you see that we've grabbed the top graphic and the bottom graphic, and we've brought them over into the slide, and we've enlarged them, we've changed the color of the 2 areas we're interested. One is how much it relies on individual contributions to show people how important their donations are. So basically, you can take an ordinary corporate document with very high quality graphics, and you can grab those and use them for a purpose where you adapt them a little bit. And I have how it works here, so we'll just look at that. Hopefully this starts on its own. If not, I'll hit this. That's not good. That was supposed to be a kind of video demonstration. I don't know how else to get it to work here. I guess we should have tested that part. Okay, so I'm just going to go back to that slide for a second and just manually walk you through what we did. So basically, we took those graphics, we grabbed the, you see the logo up in the very corner of the home page, of the front page of the document, and so we grabbed that, and in grabbing it, we then grouped it to make sure that it would scale properly, and then we were able to enlarge it, we could annotate it, we grabbed these parts of the slide, and we were able to do a lot, but we were also able to really leverage those graphics that were professionally designed in a way that was very powerful. I can show anybody who wants to see the video demonstration on my laptop after this if you want to take a look at it. I don't know why it didn't work here in this PDF. So then we'll move on to the next product, which is Visio. So a lot of people will receive Visio floor plans, layouts, diagrams, and they'll receive them from maybe a floor plan from somebody in the company. It was done a year ago. They want to be able to modify a few things, move a few chairs and tables around. What you can do with a PDF is open it as an editable Visio diagram. You can specify which page you want to open. You can scale the drawing to, you can scale to a drawing or to a page size. Remember that with PDF is a page format. So in things like CAD and Visio, those are more spatially oriented. They're based on scale. And when the PDF is created, all of the dimensions are lost. You no longer know really what the measurements are. You just have a scale, a page, a drawing that's scaled to a page. You can emulate PDF cropping. You can rotate, you have editable text with kerning and font substitution, and a lot of these features are ones that have been developed to compensate for differences between PDF and the target formats. So, for example, you might have Bezier curves in PDF, but then in a format like WMF it doesn't support Bezier curves, so we have to create polylines. So there's a lot of work that's gone into compensating for the differences in formats. You can do things like recognized objects. A circle or an ellipse is a collection of Bezier curves and arcs, and we can look at it and say, hey, the way that's set up and the way that they're connected, it looks like a circle, acts like a circle, let's make it a circle. And chances are it's a circle, and if it's not, then the end user can look at that in the end and change, modify whatever they need to. As far as AutoCAD goes, there are a lot of solutions out there already for opening and editing PDF drawings in CAD. Autodesk themselves include a feature in AutoCAD which allows you to open a PDF file. You can specify the scaling factor. Again, same thing with Visio. When you have a PDF on paper, it's a page size. So when you bring it into CAD, you have to be able to add the scale, add the dimensions, and hopefully you know that from the legend on the drawing. You can see what one DXF unit equals in terms of feet or inches or meters. You can extract drawings from multi-page PDF files. You can use the layers in PDF to combine, merge, create separate files for each layer. More features that have been sort of compensated for are being able to render paths as polylines or polygons, being able to recognize dashed lines, which when you, with the PDF, just sees a dashed line as a bunch of very small dashes. And technology like this can go in and say, hey, the way that's behaving, we think that's a line segment, so turning it back into a line segment. Adapting line widths, ignoring paths, text, images, keeping or removing 3D effects, and adjusting for incompatibilities. And also layers, which I talked about. And you can do this with external programs, with plugins. Many of the CAD programs are starting to add it either themselves or through OEMing technology. So in the CAD world, it's become very common to be able to open and edit PDF. This is an example of what the drawing looks like once it's been imported into AutoCAD. You can see that everything looks the way it should. One of the gotchas here is the text, because in AutoCAD, CAD programs support TrueType and OpenType text now, but they also have something called SHX text, and that's a type of text which is shape text, and it's basically plotted text. So any letter is made up of a bunch of pen strokes. And at the moment, there aren't really any good ways to recognize that text with any kind of OCR or anything. And there are companies, including us, who are working on developing that. Autodesk has a simple feature for that in AutoCAD, but it requires you to know what SHX text was used, which font was used. It requires you to know a lot in order to, for them to review that text and say, here's what we think it says. And it's, I did a lot of tests with it, and on our test files, which we've accumulated over many years, and it rarely got it right. So it's a really difficult thing to do well. So the next thing we're going to talk about are servers and APIs. So these would be workflow solutions. This is an example of companies we've worked with and the ways that they have implemented solutions that focus a lot on the graphics content in PDF files. I'm just going to scroll along here for a second to get to my point. Okay, so they've implemented some type of PDF document process automation or service related to vector graphics in some way. They fall into a few categories. One would be content management, another technical publishing, and then workflow in general. So if we look at the CMS and publishing examples first, on the left you have SDL. They're a tech pubs company. They create products for example, Merck uses their software for their FDA submissions, which are very long, involved documents. And they wanted to be able to make sure that the graphics from PDF could be inserted as EPS to neutralize font issues, because there's a lot of issues around fonts, as we've all heard. And when you have these complicated equations for pharmaceutical compounds, it's very easy for that to get off a little bit. And when that happens, the whole submission falls apart, because that compound is what the whole submission is about. So we find ways to do things like render the equation fonts as Bezier curves. So it looks exactly right, no matter what happens to it after that. So in that case, it's been reduced to, the data has been taken out of that equation. You wouldn't be able to open it up again in MATLAB or whatever you're using, but you do have an exact representation that can go through your document system now, and you never have to worry about it losing its meaning. So there's that example. So there you ensure your WYSIWYG representations. Another example in publishing is ABB, who converts PDF as well as EPS and AI, which are all kind of formats of PDF, into WMF print streams in their Link 1 publishing and viewing system to produce parts catalogs. NXP Semiconductors and a spin-off, Nexperia, they convert PDF into SVG and EPSF for their TechPub system. And Bosch does something similar, going from PDF to EPS and SVG. A lot of companies are interested in going from PDF, the graphics in PDF, to SVG because of the web. That's the HTML standard vector graphic, and they're trying to get their systems to be more browser-based. The other companies on this slide are doing volume automation of reports, statements, and direct mail. When converting PDF to WMF, EMF print streams, they merge graphics and text from the PDF file. The text is pulled from the PDF as ASCII and then placed precisely on the WMF form, which may be a statement or check. Change Healthcare, who we all know as WebMD, they convert 10,000 page plus PDF documents into automated WMF, EMF print streams as a service business for their healthcare providers. In a fork, they also extract selected ASCII text from the documents to populate their data management system. First Hawaiian Bank and Bank of the West have similar operations where they process 10K plus page documents their PDF mainframe reports to extract and present text within a fixed 132 character per line constraint. And then they merge their logo with it and regenerate all of that as a PDF. So sometimes it's PDF in, PDF out, but you're doing a lot to the PDF to add value to it in that process by using the value of the object data. Examples of workflow would be Reuters, who's converting PDF-based Oracle reports and casting them to the browser as SVG. And Lufthansa also does this by converting flight navigation maps from PDF to SVG for web access. So that sort of wraps up these command line examples. And then what we'll do next is move to examples of where developers can use an API to do a lot of these things. First off is PDF conversion. And with just two API calls, a conversion solution can be implemented in half a day in an application to allow it to open and edit PDF files. It's becoming a checklist item to add support for PDF import edit in commercial applications. And conversion is not always straightforward. In order for it to be done well, there has to be compensation for differences in PDF and the target format, as I mentioned already before. Things like PDF cropping, line type definitions, layers, and fonts. By mapping your format to PDF through use of an API, you can also add features like snap to an underlay or viewing to your software or service. Matching PDF to another format is never a one-to-one exercise. So these compensations become very important. Examples here would be an example where somebody adds, Graybert, they add PDF import to their application, whereas DraftSite, they create a plugin to also be able to get a little bit of revenue for that functionality from their customers. And then for laser cutting machines, you can, now they expect DXF files from their customers, which are, not everybody can create a DXF file. So by allowing the customers to give them PDF, they expand their base for the kinds of documents that they can consume and then cut with their laser cutting machines. So that's a big area where PDF is becoming an import format for those sorts of machines. As far as PDF creation APIs go, there are a lot of them out there between open source and commercial solutions, and it's pretty much your choice. But when you have vector graphic intensive documents, you need to pay attention to get WYSIWYG accuracy. There are APIs to create PDF from scratch, from data, text, print streams, PostScript, EPS, and PDF, and APIs that allow you to modify that content. And we've heard some of those already at this conference, being able to merge, combine, stamp, and watermark. The example I want to tell you about here is the National Bank of Norway. They feed their economists PS, PDF, and EPS charts and graphics from various analytical tools that they use into their production system to produce PDFs for their presentations and reports, EMF for MS Office charting, and Ping or SVG for the web. So they're basically creating a graphics brokering system where they can convert and then send off graphics to multiple different systems to be used, kind of like we started out with the World Wildlife logo. Like, it would be great if that existed in one place and everybody can use it. But what happens today is people just sort of take a screen snap of a logo, they stick it in something, it gets all skewed or resized, and it looks awful. So it's a way to kind of ensure quality. Okay, so with the Bank of Norway, they take their, they also add their logo and page numbers to the document after they do all of that work. We're going to have to finish up pretty quickly here. I knew I had a lot to go through. PDF object access APIs. This is a really interesting area of development. It gives you deep level control for pre-processing PDF files. You can extract or search for objects on a page. You could create your own conversion engine with no intermediate step or print driver, which gives you better performance and better quality. You can find text object strings and then pass them to something. You could perform operations on object data, like find it and replace it. You could delete object data. You could change attributes of the object data, and you can implement features like snapping. Two customers that use this type of API that I know of are the Open Design Alliance, which manage the DWF format that is outside of AutoCAD. And they created it, they used it to create a PDF underlay for the format and to add clipping and snapping to their CAD platform. G-Star CAD mapped their internal format to the Open Design Alliance's object database so that they could then use the objects within, they could import PDF, and they could export PDF. So we can go and look a little bit at the future. I'm just going to catch up here with my notes. I'm going to show you a couple of short-term projects which we view as important, and I'll also talk briefly about some game-changing possibilities. What sort of short-term challenges are there to improve vector extraction? They would be, first would be plotted text recognition. This is what I talked about with the SHX fonts and AutoCAD. You can have PDF files that have these plotted text in them, and right now there's no way to do OCR on that. And there's a couple of reasons why. One is because it's really hard to know the difference when fonts get involved, like what an O and a 0 are, how you tell the difference between them, how do you know which one it is. And then also, for example, this Q, that's actually a compound object. It's an ellipse and it's a straight line, and it takes two objects to make a Q. So there are a lot of issues in that, so we're working on that. Being able to recognize hatch fills. When you open up a PDF file in a CAD program and there's something that has a hatch fill in it, it doesn't see it as a circle with a pattern. It sees it as a circle with 20 lines in the middle of it, and this explodes the file and makes it very large. So being able to see that hatch fill as a hatch fill and replace it as a pattern, that's an important advancement to be able to make. And then we also talked about fonts and how fonts are difficult. I mean, not only is there font mapping issues, but even within fonts, if you use Windows 7, you probably have Arial MT on your system. And if you use Windows 10, you probably have Arial on your system. Those are exactly the same font. But does the PDF know that? No. So when you have a PDF with Arial MT and you send it to somebody who has regular Arial, and it won't know that that's the same Arial. So there are things to do to make up to understand the font variant name recognition, recognize the names that are in the PDF files. And then we also have to look at how graphics fit into the PDF and association and the ISO standards, because now the focus, as we see at this conference, is a lot on accessibility. It's maybe not as much yet on the idea of using the PDFs that exist to help people transform their digital businesses to find the intelligence that exists in their organization today, and we can do that a lot through this. So the last thing, real quick, I know my time is up, is the long-term goal we have is we're working on something called vector search and action. And in this case, this is part of the digital transformation. Organizations have a wealth of information locked inside their PDF-based visual content, and mining it can lead to better business intelligence, streamlined workflows, and result ultimately in an increased competitive advantage. The solution for this is something we call search and action. And it needs a platform or API that enables the enterprise to use the intelligence stored in the visual content through facilities for retrieval, viewing, discrete search and action, dynamic modifications, analysis, publishing, and more to find, correlate, analyze, and publish business results. We've created a prototype, which we developed with grants from the Netherlands Government Innovation Funds. We do our development in Holland. This has two parts to it. The first is compound object recognition, which is where you can pinpoint specific objects within files. A compound object would be, we have a simple object like a circle, but a compound object would be like a CAD part. And you would be able to search a parts catalog for that CAD part. And you would be able to find other CAD parts that fit, that it looked like, both at that size, at scale, And at any rotation, any orientation, you would really be able to start looking into the graphics of files. And in order to operate this system, you need to have an object query language. And so these are the two parts. It allows for a lot of dynamic functions within the graphics in PDF. It allows data-driven graphics, merging of files, stamping, watermarks. That's it. That is it. And so if you have questions, I'm around. You can ask me. If you want to see the way that PDF can be used in PowerPoint, that little video I was going to show, let me know. And if you want to contact me after, there's my information. Thanks a lot.